So we are going to continue from where we stopped. I think we stopped at in chemistry we stopped at mixtures, compounds, and elements. So we are going to continue from there. Now today we are going to be looking at separation techniques. Now what do we mean by separation techniques? From the word separation, that means we have two or more things that have come together and we are looking for a way to bring them apart. So you are looking for a way to bring them apart. Now what do we call a separation technique in chemistry? So separation techniques are methods that we use to separate mixtures. Now this is what is very important. What we are separating are going to be what? Mixtures. We don't separate compounds using separation techniques. We don't separate compounds using separation techniques. Why? Because compounds have reacted chemically together, so there is no way you can separate them. But for mixtures that do not react chemically, it's going to be very easy for us to separate them, since each individual particle is still part of that thing that you are having. It's still inside. Just like you mix rice with beans, what will you have at the end? You have rice and beans. So what this means is that even if you want to separate, since you are still having your rice and your beans, that means you can still go back to rice individually and also beans individually, rather than when you mix hot water, when you mix it with elubo, which is yam flour, what will it become? It will become amala. Now can you separate this amala back to hot water and elubo? Is not possible, because this one is not a mixture. They have reacted chemically together, so it is now what? A compound. It is now a compound. Now, so those examples of separation techniques that we have, those are the ones that we have listed here. So we have evaporation, we have crystallization, we have fractional crystallization, we have precipitation, we have distillation. So like that. Now what you are going to do is you are going to take them one after the other and try to look at how we can use this to separate whatever we are having, although there are still many more that I did not list here, but let's just first talk about this first. Now, so what is evaporation? When are you going to be using evaporation? Now evaporation is a method of separating a solid solute from a solvent. Now you need to know these words. What do you call a solute and what do you call a solvent, and also what we call a solution? Now what we mean by a solute? A solute is just something that can dissolve in another thing. Something that can dissolve in another thing is what you call what? A solute. For example, if you mix salt with water, what are you going to have? You are going to have a salt water solution. Water solution. So that means that we are having salt inside water. Now this salt, which is our sodium chloride that will dissolve inside the water, is what we call what? The solute, because it is the one that will dissolve inside another thing, inside the water. So we call it the solute. Now what do you call a solvent? Now our solvent here is water, so the solvent is the one that dissolve another one. So it is not every time, note, it is not every time that your solute is going to be a solid, because sodium chloride is actually a solid, and your solvent is also going to be a liquid. In most cases, majorly, the solvent is always a liquid. In most cases, our solvent is always a liquid. So these are our solvents, these are our solutes. So in most cases, our solvent is always a liquid. Now the solute is not necessarily a liquid. Our solute is not necessarily a liquid. For example, you can also mix, which liquid can we mix with water that we mix? You can mix maybe Fanta. You can mix it with water. So in this case, the Fanta is now what? Is now the solute. Although it is now in liquid state, but it does not matter. So anything that you dissolve inside another thing is going to be our solute, and that thing that dissolves the other thing is going to be the solvent. So they now say we use evaporation to separate a solid solute from a solvent. Now we are going to use to separate a solid solute from a solvent. That means we can only use it when we are having a solute that is solid. For example, we have our table salt. When we mix it with water, what you have a salt solution. You have a salt solution. Now this is a solid solute, this is a solvent. Now you're having a solution. Now this is what we call a solution. A solution is what you get when you mix two things together, especially when you mix something that can dissolve inside what can dissolve it. Then what you are going to have is going to be a solution. For example, if you mix sugar, if you pour sugar inside water, it's going to dissolve and form sugar solution. So this is what you call a solution. Now we use this method for solids that are not easily decomposed by heating. Now what we do in evaporation is that we are going to, since we have mixed salt and water together to form salt solution, we now want to get back our salt. Now note something about evaporation. Evaporation is mainly concerned about the solute and not the solvent. Evaporation does not consider the solvent at all. It only considers the solute. So which means that whenever you want to use evaporation, you are going to be able to obtain your solute, which is this salt. If it's this one, it's going to be this sugar. But the solvent, you can't get back your solvent. Your solvent is going to waste. Now how do you carry out evaporation? Now what you are going to do is, this solution that you have, you are going to heat it. Now when you heat it, the water is going to do what? It's going to evaporate. That means it will change to gas and leave. Now you will now be left with what? Your salt. You are going to be left with your salt. Now since we said the water is going to evaporate, that means the water is going to get wasted. There's no way of getting our water back. Now another thing that we must know about evaporation is that, we said we are going to heat it. We are going to heat it. Now heating it means we are heating both the salt and the water, since they are together. So once you are heating the solution, you are heating the salt. At the same time, you are also heating the water. So the implication of this is that it is possible that heat will damage our salt. So in the case of the normal salt, which is sodium chloride, our sodium chloride is not going to be damaged. Why? Because sodium chloride is actually a salt that is stable to heat. That means that heat does not decompose sodium chloride. But in the case of sugar solution, you can use evaporation to separate. Why? Because you know that evaporation is concerned about the solute, and in this case sugar is not a solute. It's not a solid that is stable to heat. That means that when you heat sugar, something is going to happen to it. You can try this at home, and I think I've tried it before. So just pour sugar inside a container, then put it on fire. What do you notice? It is going to turn to a liquid, something black. So that means what? The sugar is not stable to heat. So that's why you can use evaporation to separate this, because the sugar will be affected, and it's the sugar that you want. But you can use evaporation to separate this because it is the salt that you want, and the salt will not be affected. So note that we only use evaporation to obtain the solute, and it must be a solute that is what? That is not easily decomposed by heating. So a good example is when you want to obtain your sodium chloride from water solution, then you can use evaporation. Now let's look at the next one. The next one is crystallization. Now, so crystallization is suitable for dissolved solids, look at this, that are easily decomposed from heating. So that means that when you want to use evaporation, you look at the salt or the solute that is dissolved in the solution. Can heat withstand heat? If it can withstand heat, you go for evaporation, since it's the solute that is your concern. Now if the solute is your concern and you discover that that solute cannot withstand heat, then you go for crystallization. So crystallization, we use it where those solutes cannot withstand heat. So now they are trying to give us examples of salts that decompose on heating. That's examples of salts that they can't withstand heat. Now they are not much. Now we have carbonates. All carbonates. Carbonate is any salt, any compound that you see that they write that contains CO3 is a carbonate. And it is no hydrogen that is with it. Note that. Maybe it's not hydrogen that is here. Maybe it's another metal like sodium. Sodium can be there. Calcium can be there. It can be anything, but it must not be hydrogen. So those are salts of triazocarbonate. Now, so all triazocarbonates are what? They decompose on heating. Only two of them do not decompose on heating, which are what? Triazocarbonate of potassium and that of sodium. Which means that if you have NaCO3, this one will not decompose. Which means this one is stable. That means that you can use this first method for it, evaporation, since it is stable. If you also have K2CO3, you can also use evaporation for this one, because potassium triazocarbonate is also a stable salt which will not decompose on heating. But if you have any other triazocarbonate, let's assume that we have maybe magnesium triazocarbonate, please don't use evaporation for this because it's going to decompose. So you use crystallization for it. Now, apart from triazocarbonate, we also have all nitrates. All nitrates, any nitrate at all. So be it sodium nitrate, it is not stable. Be it potassium nitrate, it is not stable. Be it calcium nitrate, it is not stable. So all nitrates are not stable. Now, sulfate of heavy metals like iron, copper and zinc are not stable. So you should also know that the sulfate of these guys are not stable. So when you see a sulfate that it is iron, maybe you have iron sulfate, FeSO4, or you have, it can also be Fe2SO4 3. So this is also iron. Both of them are iron sulfate, but one is iron 2 sulfate and the other one is iron 3 sulfate. So or you have copper with sulfate, or you have zinc with sulfate. So all these are what? They are not stable to heat. That means that you are going to use crystallization. You can't use evaporation. So chlorides of ammonia are also not stable. All other chlorides are stable. If you have sodium chloride, you see, we used evaporation for sodium chloride because it is stable. You can also use evaporation for potassium chloride because it is stable. But don't try evaporation with ammonium chloride because it is not stable. NH4Cl. This is not stable. So you can't use evaporation for it. So that's all that we have. Now, here the solution is first heated to saturation. So how do you use crystallization? So how you use crystallization is that when you already have that salt in solution, let's say we have ammonium chloride, since this is not stable to heat, it is in water. So you are going to have ammonium chloride solution. Now, how do we get back our ammonium chloride? That's the issue. So we check, is ammonium chloride, is it stable to heat? If it is stable to heat, we use evaporation. If it is not stable to heat, we use crystallization. But we already know that it's not stable to heat because it was mentioned here as part of the salt that is not stable to heat. That means we are using crystallization. Now, how do you do crystallization? So you already have ammonium chloride inside water. So you now heat it. Now, the heating here is not like the heating of evaporation. If it is evaporation, you heat it till the water that you have is going to what? Evaporate. It's going to leave and turn to gas. But in this case, you only heat it very little. You give it very little heat. Now, the reason you are heating it is just to remove some of the water, not all of the water. Now, after you have removed some of the water, the solution that you are going to be left with is now going to be very concentrated. It was dilute before because there was what, a very high amount of water, but now you have heated it, some of the water has left, so you now have little amount of water. Now what will now happen is that this ammonium chloride will now start crystallizing out of the solution. Now what we mean by crystallizing is that this ammonium chloride is already dissolved in the water, but you now start seeing it as little crystals, something like this. They are going to form like crystals. So I'm going to try to see if I can find a video of how this happens and send it, so that you'll be able to understand the meaning of this formation of crystals by ammonium chloride. Now how do you make the crystals to form? Now you have heated it before. You just heat it, give it very little heat, then you cool it. So after cooling it, that's when these crystals will now start forming. So this crystal will now be ammonium chloride coming out of water. Now another thing about it is that if this crystal do not start forming, there are two ways you can make the crystals to start forming. The first way is by what? By adding grains of the salt. That means that you add some little amount of NH4Cl to the solution, so that the crystal will start forming quickly. Or you scratch the inside of the container. So you either do this, you add little amount of the salt to the solution so that the crystal can form, or you scratch the inside of the container. Now note, the salt that we obtain from here is going to be very pure. The salt is going to be very pure. So that's how we carry out crystallization. Now another one that we need to know is fractional crystallization. Now for fractional crystallization, it is almost the same thing as crystallization, just that in this particular case, anywhere that you see that they say fractional means there are more of what you want to separate. So it is still the same thing as crystallization, but they are adding more. So which means in this case, instead of having only ammonium chloride that is dissolved in water, what you are now having is, we still now have another solute again. So let's say sodium chloride. So meaning that you now have ammonium chloride and sodium chloride in water. So how do you now separate them? Now we won't be able to use fractional crystallization for this. Why? Because sodium chloride can be separated by evaporation and not crystallization. So we need another salt that is also not stable to heat. Sodium chloride is stable to heat. So let's think of another salt that is not stable to heat. They have told us here that all nitrates are not stable to heat. So let's try a nitrate. So let's say we have sodium nitrate. So if you look at this, this is a salt that is not stable to heat. This is also a salt that is not stable to heat. So that means that we can't use evaporation. We will now use crystallization. But since there are now two of them, that means we will now use fractional crystallization. So fractional crystallization depends on the temperature, the solubility of this guy and this guy. So which means that we still carry out the same process. We heat this solution. When we heat it to a particular temperature, we heat it, give it very little heat, so that this guy will not be affected and this guy will also not be affected. We still carry out the same procedure. We now cool it. Now after cooling it to a particular temperature, we are going to discover that any one of them that has that particular crystallization point is going to come out of the solution. Let's assume that ammonium chloride crystallizes at, this is just an assumption, maybe it crystallizes at 50 degrees Celsius and sodium nitrate crystallizes at 40 degrees Celsius. So what you are going to do is that we now heat this solution to a temperature of about, let's say, 55 degrees Celsius. So after it has reached this temperature, what will we now do? We cool it, right? Now after we are cooling it, you see that as the temperature is coming down, which one of these two will we reach first? We are going to first of all reach 50 before we reach 40. So by the time we get to this 50 degrees Celsius, this ammonium chloride will just crystallize. That means it will come out of the solution. So that means that by the time we now go below 50 degrees Celsius, there is no longer any ammonium chloride in the solution again. So the solution now contains only water and what? And sodium nitrate. So that by the time we get to 40 degrees Celsius, sodium nitrate can also come out. So that is what we call what? Fractional crystallization. So that's what we mean by fraction. From the word fraction, that means when we're talking about fraction in mathematics, we say what? A fraction is a part of a whole. So fractional crystallization means that what? You are removing a part, then you still later remove another part. So that is what happens with fractional crystallization. Now, so let us quickly talk about precipitation. Now, where do we use precipitation? We have to understand what we are doing in precipitation. Now, precipitation, you use precipitation when you have two liquids. Let's say we have liquid A and we have another liquid B. Now these two liquids, they can mix. These two liquids are miscible. What we mean by miscible is that you can pour A in B and they will mix together, not that they will stand separately. Take example of palm oil and water. If you pour oil in water, will they mix? No, they can never mix. You will discover that the oil will be on top of the water. So these ones are not miscible liquids. So when you want to use precipitation, you must make sure that you have two miscible liquids. Now you now have a solute, which is a solid that can dissolve in one of the liquid but cannot dissolve in the other one. I hope you get what I'm saying. We are going to have a solid that can dissolve in liquid A, but it cannot dissolve in liquid B. Now what will now happen is that we are going to mix. When this solid mixes with liquid A, this solid can mix with liquid A, right? So when this solid now mix with liquid A and we want to remove this solid from liquid A, what will we do? We just look for liquid B and pour it inside the mixture of these two so that this solid will now come out. Let me give you a very good analogy of this. What we are saying is that A is a friend of B. That means A is friend with B. That means that A and B will mix, right? Now, knowing that, now this solid is also a friend of A. That means that this solid will dissolve in this liquid. So take that. But this solid is an enemy of this liquid. Now just imagine a situation where we have this liquid and this solid when they are together. That means we have two friends together, and this liquid B, which is now an enemy, now comes. You know that this liquid is a friend of the first liquid, so that means that the first liquid will still be there, but is an enemy of this solid. So what will happen to the solid? The solid will have to leave because it can't stay with its enemy. So that is what you call what? Precipitation. I hope you get this. It's a little bit complex, but it's something that you can get. So we have a liquid A, which is a friend of this solid. They are friends. This liquid is also a friend of another liquid. So whenever I use friend of, it means that they can mix together. So that means this solid can mix with this liquid can mix with this liquid, but this solid cannot mix with this liquid. That means they are enemies. So now imagine that these two friends are staying together and this liquid, which is an enemy of this solid, now come to join them. What will happen? This solid will have to leave because it is not a friend of this particular liquid. So that is what we call what? That is what we call precipitation. So look at what they said. We have a solid that can dissolve in a liquid but not in another liquid. So when the two liquids are miscible, so we make sure that the two liquids are miscible. That means the two liquids must be friend. Then the solid is friend to one of the liquids so that the solid can mix with its friend. Now when the solid is mixing with its friend, then the other friend of that liquid now come. That friend will now act as an enemy to this solid, so that this solid will now have to run away. It can't stay with them. So it can only stay with its friend and not with its enemy. So that is what we call what? Precipitation.